Question 2c. Deduce that for a fixed x in the real line, we have that sine of x is equal to this expression. So how will we go about that? We recall the information from before. So from above, we already know this. I'm just copying it from above. And in this particular question, our function fx is sine x, which is of class C infinity, which means there are infinitely many derivatives, and they're all going to be continuous. Our interval is the real line, and our value of a is equal to 0, which means we're centering around 0. So remember, our goal is to show sine x equals to that expression. So from before, we know this. So this first inequality there, that's by question 2b. And then we also know that this term approaches to 0 as k approaches infinity. And how do we know that? That's by question 2a. So in other words, so by squeeze theorem, we see that the limit as k approaches infinity, that the remainder term r goes to 0. So based off the information that we know up here, as k goes to infinity, if r is going to 0, then it stands to reason that the p terms converge to f. Right? If the r terms converge to 0, the p terms converge to f. So then, fx is equal to the limit as k goes to infinity of pk0x. And that's going to equal to limit summation I goes from 0 to k, f to the ith derivative over I factorial, x to the power I. It should be x minus a, but a is equal to 0 to the power I. And quite obviously, you could just write that like this. Okay. So what remains to be done is to figure out what f to the power I at 0 is. So we recall fx is just sine x. And remember, the derivatives of sine goes sine, cos, minus sine, minus cos. So f of 0 is just 0. F prime of 0, so that's cos of 0, that's 1. F double prime of 0 is just minus sine at 0. F triple prime at 0 is minus cos at 0. And f quadruple prime at 0 is sine of 0. So really all we've done so far is we've went in a circle. So it goes 0, 1, 0, minus 1, 0, 1, 0, minus 1. So in general, because we only care about the odd powers, the even powers are, you're always going to just get a 0. We have that f to the power 2n plus 1 at 0 is equal to minus 1 to the power n, where n is a natural number, greater or equal to 0. And what I mean by that is, if n is equal to 0, then f to the first derivative at 0 is equal to 1, and that matches with minus 1 to the power 0. F to the power 3, right? That's n equals to 1. That's minus 1, that matches with minus 1 to the power 1. That's just true in general. So that's just an aside. That's an aside. So now we take this information and we substitute it back into, this information back into there. And keep in mind, whenever the derivative is an even derivative, it's just equal to 0. So therefore, sine of x, which is just f of x, is equal to the sum f 2i plus 1 at 0 divided by 2i plus 1 factorial x to the power 2i plus 1. We continue to simplify. And we're done. And this is valid for all x inside the real line. And that's it.